In this video I want to go over outliers. We talked about how to find outliers on a spreadsheet, but I want to just reinforce the concept behind outliers. As I mentioned in class, there's no standard rule for finding outliers in all the sciences. It's really experiment specific and discipline specific, but we're going to try to just take a general approach in our class, and we'll have an outlier guideline or a guideline to find outliers. But before I go into the particulars of that, I just want to have a little example here. So perhaps we have a cluster of data points in this area of a number line. So think of the arrow as a number line. Most of our data is solidly bunched together. Perhaps more of it is clustered in the center of that main data set. And then there's less and less data the farther you go out from that main data set. So the question is, should we honor all of this data for our analysis, and should we draw a conclusion from all of this data, or only some of it? Well, we can't just arbitrarily say, for example, that we don't like the looks of these data points that are far out on the extremes. We need to have a process that we follow to identify which data points we're not going to honor. So let's take a look at this a little more closely. Perhaps if we were to go on a spreadsheet, the computer might identify the data point that's in this region of our data set as being the third quartile, or third quartile. That means that 25% of the data lies higher in value than that point. So Q3. 25% of the data is off to the right of that. And then the computer might identify, for example, that spot as Q1. In other words, 25% of the data lies to the left of that data point. And the region between Q1 and Q3 is called the interquartile range, or IQR. Okay, so that's some of the terminology we need to master. So for the purposes of our class, we're going to consider any data that lies beyond 3 times the interquartile range away from the main data set, Q1 or Q3, as an outlier. I know that's an earful. Consider this IQR space right here, this distance on the number line, from Q3. If we start at Q3 and we go 1 IQR distance over to the right, then it might be somewhere in this region. That's a dashed line. So that's 1 IQR away. What if we go 2 IQRs away from Q3? We might end up around there. So that would be a second IQR. And then if we go a third IQR away from Q3, we might end up in that region. So that means that these 2 data points are outliers because they lie to the they lie beyond the third interquartile range away from Q3. So once again, each one of these is an IQR. Apologize for the sloppiness of this, and then an IQR. So there are 3 IQRs. And then the same thing on the negative side. So we have one IQR might be at that spot. A second IQR might bring us roughly to there. And a third IQR might bring us, let's just say that it's to right there. So in that case, these data points there would not be outliers because they are not beyond 3 interquartile ranges away from Q1. So once again, this is an IQR, and then this is an IQR space, and this is an IQR space. Okay, now that you have the concept down, see if you can do this in your head. What if we have a data set and ask the computer to find our first quartile and it equals a value of 50, let's say, grams. And the third quartile the computer identifies as 60 grams. Again, once again, this means that 25% of the data in the data set has a value less than 50 grams, and 25% of the data in the data set has a value greater than 60 grams. Here we see that the IQR is simply the distance or the difference between them, which would be 10 grams. So my question to you is this. Are these numbers outliers? 16 grams and 85 grams. Are they outliers? See if you can do it in your head. You might want to pause this if you need a little time. Okay, if you've done it in your head, you should have found that 16 grams is an outlier because the minimum value that we would trust is 20 grams, and 85 is not an outlier because the maximum value that we would trust in our data set is 90 grams.